All right, so you ready to dive into something really cool?
Always.
This time you've given us like a set of slides titled Learning is Fun.
Oh, I like this already.
Yeah, and each one like hints at a computer science concept, but it's through these metaphors, these visuals.
Interesting.
It's like someone took programmer humor and like made it into an escape room or something.
These slides are honestly brilliantly designed. I mean, using metaphor to unpack these really complex ideas, make them more accessible. It's honestly a fantastic way to learn.
Yeah, it's not every day we get to unlock programming secrets, through riddles and stuff.
Right.
By the end of this deep dive, you're not only going to like grasp these core concepts,
Yeah.
but you'll also walk away with a totally fresh perspective on like problem solving in general, right? Yeah.
Exactly. It's all about connecting these ideas, seeing the bigger picture.
Okay, so first up is digital puzzles,
Yeah.
a programmer's playground.
Yeah.
I love that imagery.
Yeah.
But what does it actually mean? Like to approach code like it's a puzzle.
Okay, so imagine you're facing this big, complex problem.
Mm-hmm.
Just like solving a jigsaw puzzle, you don't just, attack the whole thing at once. You break it down
Right.
into smaller, manageable chunks. Each line of code you write, it's like fitting a puzzle piece into place. And the real skill is in using logic, using creative thinking to find that elegant solution.
Ah, so it's about like seeing both the forest and the trees.
Yes.
You need that strategic vision, I guess, to really excel.
Exactly. And just like with a puzzle, there might be multiple solutions, right?
Yeah.
But finding the most efficient one, the most elegant one, that's key. It's not just about making it work. It's about making it beautiful.
Okay, on to the next challenge, Russian dolls. Love it.
Classic.
The slide says, I'm a problem solver, a self-caller. Is this about like self-driving cars that everyone's talking about these days?
Well, while self-driving systems actually use this concept extensively,
Okay.
this slide's about something a bit more fundamental, recursion.
Recursion.
Yeah, so think about those dolls, right?
Yep.
Each one nestled inside a larger one.
Yeah.
Recursion is similar, okay? It's a function that basically calls itself to solve smaller subproblems, just like opening those dolls one by one until you reach the tiniest one.
So it's like breaking down a task into smaller, like self-similar tasks.
Yes.
Sounds incredibly efficient.
It is. And its elegance, it really lies in its ability to solve complex problems with remarkably concise, elegant code. It's like using the same tool at different levels to solve a problem, step by step.
This is where it gets really interesting, okay? I'm a repetitive dancer. That definitely doesn't sound like puzzles or dolls anymore.
It's a bit different, yeah?
This feels more like, I don't know, a set dance move.
You're picking up on a crucial difference. This slide is all about loops, okay? A fundamental concept in programming. Imagine a clock's hands,
Okay.
moving in a continuous cycle. Loops are instructions that repeat, just like that clock, until a specific condition is met. They're I guess you could say, the workhorses of programming, automating those repetitive tasks.
So instead of solving a problem once, it's about doing it over and over and over again until you get the outcome you want.
You got it. Think of it as like a tireless worker, faithfully carrying out a task until the job is done. Whether it's sending, hundreds of emails or analyzing massive data sets, loops make it happen without breaking a sweat.
Okay, from dance moves, we're moving on to reading the news. This slide talks about being a watcher, staying informed, almost like a news reporter.
You catching on? This one's all about event listeners.
Okay.
Think about it. You don't just stare at a newspaper waiting for something to change, do you?
Definitely not. I have things to do.
Exactly. You go about your day, and when something important happens, the newspaper, it reports it, right?
Right.
Event listeners work similarly. They allow programs to listen for specific events, changes, like, say, a user clicking a button or new data coming in, and then the program can react accordingly.
So it's like having, a sixth sense, always aware of what's happening and ready to respond.
Precisely. This makes programs dynamic, interactive, able to adapt to user actions or changes in their environment, all in real time. It's what makes things like online games, interactive websites, it's what makes them possible.
Okay, this next slide just shows a single key. And it says something about being like a solitary soul. It feels kind of mysterious.
Yeah.
Like we're getting into digital security now.
You're right to be thinking about control and access.
Okay.
This slide is about the singleton pattern. Singleton.
Yeah.
So think of it like a vault.
Okay.
With only one key. In programming, a singleton makes sure that only one instance of like a particular object exists at any given time.
Okay, so instead of having like multiple copies floating around, there's just one central authority.
Right.
But why would you want that?
Control consistency. Let's say you're dealing with something like a database connection.
Mm-hmm.
You wouldn't want different parts of your program opening separate connections, willy-nilly. It would be chaos.
Total chaos.
Right. A singleton makes sure there's just one connection, managed carefully, prevents conflicts, keeps things, running smoothly.
So it's like having one air traffic controller.
Exactly.
In the entire program.
Yeah.
Making sure everything stays organized, avoid collisions.
Precisely. It's about elegant resource management.
Okay.
And preventing those digital traffic jams, right?
I like it. This next one seems pretty straightforward.
Okay.
Just like a bunch of paper clips linked together.
Simple but powerful.
Yeah. What's so special about that?
Don't let the simplicity fool you. This, my friend, is a visual representation of a linked list.
Okay.
A fundamental data structure in computer science. Each paperclip, that represents a node, a container that holds data.
Okay.
And each node points to the next one in the sequence.
So it's like a chain.
Yes.
Where each link holds information.
Yeah.
And then it leads you to the next.
Exactly. And just like a chain, incredibly flexible. You can easily add or remove links without, needing to rearrange the whole structure.
Mm-hmm.
Makes it perfect for things like music playlists.
Oh, right.
Or even the history of pages you visit in your web browser, right? Constantly changing, adapting.
That makes sense, yeah. You can shuffle songs around, add new ones, remove ones you're tired of, all without messing up the whole playlist.
Precisely. And because each link only needs to know about its neighbor, linked lists, very efficient, storing, retrieving data, even when you're dealing with huge amounts of information.
Speaking of efficiency, this brings us to our next slide, which is literally a map.
I like it.
So I'm guessing this is about, like, finding the best route.
Okay.
Like a GPS.
You're on the right track. This slide represents the fascinating world of algorithms.
Algorithms.
Yes, think of an algorithm like it's like a set of instructions.
Okay.
A recipe for solving a specific problem.
Okay.
Just like a map helps you find the shortest path.
Yeah.
Between 2 points, an algorithm guides a programmer to find the most efficient solution.
So it's not just about, like, getting from A to B. It's about finding the smartest, fastest way to get there.
Exactly. And just like there are different routes on a map, right? There can be many different algorithms to solve the same problem. The key is choosing the one that's most effective and efficient for the task at hand.
This is blowing my mind. It's amazing how these concepts are hidden in plain sight.
Absolutely.
In our everyday lives.
It really highlights the creativity, the ingenuity at the heart of programming.
Yeah.
Speaking of creativity, our next slide looks a little bit more like an art studio.
I know, right?
In the computer lab.
It shows this, like, digital painting.
Yeah.
And it talks about a digital artist learning and growing.
Yeah.
Is this about those AI art programs I've heard so much about?
It is related, but this slide represents a much broader concept, machine learning.
Okay.
Think of it like this. Imagine an artist, right, who gets better with every stroke of their brush.
Okay.
They learn from their mistakes. They refine their technique. Machine learning algorithms, they work in a similar way.
So they're not just programmed. They're actually, like, taught to learn and adapt on their own.
Yes.
That's incredible.
It's truly revolutionary. By feeding these algorithms massive, massive amounts of data, they can identify patterns, make predictions, even create original works of art, all without being explicitly programmed for those specific tasks.
It's like having a student that never stops learning.
Yeah.
And just constantly surpasses your expectations.
Precisely. And this is just the tip of the iceberg.
Really?
Machine learning is rapidly changing the world around us. From, personalized recommendations to medical diagnoses and, honestly, its potential. It's only just beginning to be explored.
Okay, last slide. This one kind of feels like we're, like, zooming out.
Yeah.
Seeing a whole cityscape,
Oh, interesting.
Yeah, there are buildings of all different sizes, construction cranes, people moving around. It definitely gives off, like, a vibe of constant activity,
Yeah.
Evolution.
I can see that.
The title is Building the Future, Brick by Brick.
Okay.
And it talks about, like, teamwork, adaptability. Is this about city planning?
It's a clever analogy, not directly about urban planning. This slide represents agile development.
Okay.
It's a way of approaching software development that kind of borrows from that dynamic, collaborative nature of, well, building a city.
So instead of like a rigid blueprint, it's more like having a flexible plan that adapts to changes, new information.
Exactly. Think of it like this. In a traditional software development model, you'd spend months, even years, planning every little detail before even writing a single line of code.
Wow.
Agile flips that on its head.
Sounds kind of like my kind of approach, like why wait when you can just dive in and start experimenting?
That's the spirit.
Yeah.
Agile emphasizes these short cycles of work. They're called sprints, where teams, they design, they build, they test features, all in this really collaborative, iterative manner.
So it's about like embracing feedback, adapting to change, and just constantly improving with each step.
You nailed it. Agile is all about remaining flexible, responding to user feedback, and delivering value incrementally. It's a much more, dynamic and responsive way to build software, especially in today's world, this ever-changing technological landscape we live in.
It's amazing to me how, like, we started with these riddles, right? And through this deep dive, we've like uncovered this whole world of these ingenious solutions and elegant thinking. It's really incredible.
Yeah, it's truly fascinating. These concepts, while they might seem abstract, right, they underpin so much of our digital world. And the beauty of programming, it's an ever-evolving field, constantly pushing the boundaries of what's possible.
It's like you said at the beginning, it's all about connecting these concepts to the bigger picture,
Absolutely.
And honestly, I'm walking away with like this newfound appreciation for like the art, the ingenuity behind the technology that we all use every day, but honestly don't think about that much.
We take it for granted.
We really do.
Yeah.
Well, who knows? Maybe today's deep dive will inspire some of you listening out there to explore, the world of programming and maybe even create a digital masterpiece of your own. Until next time.